show of HSNEWS. We've got an excitingly educational program planned for you guys today. We'll be talking about animal nutrition. So, we'll be here in the studio for a little bit. We'll be out in the field with our reporters, Cassette and Tyler. They'll be giving you lots of good info. I'm your host, Riley, and let's get started. Our first lesson on today's menu is going to be animal diet. There are 3 basic things that animals need to obtain from their diet. So we've got chemical energy, organic building blocks, and essential nutrients. Alright, so first of all, chemical energy. Cells, tissues, organs, and basically the whole body of the organism depends on this chemical energy to survive and to have energy for just daily life. Next, organic building blocks. So basically, animals are going to need raw materials for biosynthesis. So to build complex molecules and to grow, animals are going to need a source of organic carbon, like sugar, and organic nitrogen, like protein. And the third thing that an animal needs in its diet are essential nutrients. So essential nutrients are substances that an animal requires but cannot assemble from simple organic compounds. So there are 4 types of essential nutrients. First one being essential amino acids. Next we got essential fatty acids. Next are vitamins. And then lastly, minerals. Alright, that's enough for me for now. I'm going to send this over to one of our field reporters. They're going to tell us more about essential amino acids and fatty acids. Take it away.
Thanks, Riley. Now I'm going to be talking about amino acids and fatty acids. Amino acids help to build our protein molecules. Humans and animals can only produce about 12 amino acids, so they must consume the other 8. These 8 are known as essential amino acids. And on top of that, we also have essential fatty acids that help with signaling molecules and phospholipid membranes. Now let's send it to Cassette to talk about vitamins.
Thanks, Tyler. Now, we all know how important fruits and veggies are for us, but what's really underrated is the importance of vitamins that are contained in fruits and veggies. Vitamin B is a water-soluble vitamin, and it acts as a coenzyme. Vitamin C is another water-soluble vitamin, and it's used for building connective tissue that binds together different organs in the body. There are also fat-soluble vitamins. One fat-soluble vitamin is vitamin A, and it's used in eye pigmentation. Vitamin A is extremely important in third world countries where their diets are mainly based on rice. They lack a lot of vitamin A, and that's why blindness is common. Vitamin K prevents blood clotting, and vitamin E, another fat-soluble vitamin, protects the cell membrane from damage. Vitamin D is also extremely important. I know lots of y'all like Sunny D. Well, you get most of vitamin D from the sun, so actually the necessary amount of vitamin D that you need, like to intake, is dependent on how often you're out in the sun versus how often you're not. Also, vitamin D helps with building different cellular structures, such as calcium absorption and bone formation. Too small of an amount of vitamins requires that you take supplements, but too much vitamin intake causes it to be deposited in the body as fat, and it can accumulate to toxic levels. So, though vitamins are important, it's also important to have a healthy balance. Now back to Tyler to discuss minerals.
Now minerals are inorganic nutrients that are required in small amounts, such as iron or maybe even potassium. They have a very diverse function within animal physiology. For instance, iron is used in the protein of the hemoglobin that carry oxygen throughout the body. Other minerals, such as sodium, potassium, and chloride, are used in the function of connecting nerves. However, like vitamins though, an excess amount of minerals can be toxic to the body, such as an excess amount of salt can lead to high blood pressure. Back to you, Riley.
All right, that wraps up essential nutrients. Moving on, we're going to be talking about dietary deficiencies. All right, so we have two concepts to cover here. The first one being deficiencies in essential nutrients, and the next one being undernourishment. When an animal's diet lacks one or more essential nutrients, or the animal intakes less chemical energy than is required to fuel the animal's body, malnutrition occurs. Malnutrition can be defined as failure to obtain adequate nutrition. So we're going to split this section up into two parts, send it over to the field reporters, and they'll give us more info.
Thanks, Riley. Now, nutrient deficiency is extremely important. It results in deformity, disease, and at times death. Phosphorus deficiency leads to bone frailty. But many animals have found ways and means to supplement some nutrients for others. Like some animals will look for the mineral of salt to supplement the nutrients that they're lacking. Protein deficiency is also extremely common. It's the most common in people, and it leads to impaired development in children. Vitamin A deficiency is also very common, but more in Asian countries that have their diet based in rice, and it leads to blindness and even death at times. So some people have created golden rice. It's still in the workings, but it uses beta carotene and converts it to vitamin A for use for everyone. So they get vitamin A from their rice diet. Now on to Tyler for undernourishment.
Now, on to undernourishment. Undernourishment is whenever there is not enough chemical energy being consumed. First, the body will start breaking down stored carbohydrates and fats. Then, it will go down to tearing down your proteins, which will lead to decreased muscle. Also, your brain becomes protein deficient. That is why eating disorders such as bulimia and anorexia are bad for you, because it will make you die. This also affects third world countries in Africa.
All right, people, I think it's time for a quick break. In the meantime, we hope that you enjoyed this short clip of a dog avoiding undernourishment. And we're back with our next topic, food processing. So, we're going to go through four main steps here. Number one, ingestion, taking in the food. Number two, digestion. Number three, absorption. And number four, elimination. Who put that poop emoji there? That's better. All right.
Hi everyone. In this video, I will explain to you how we get from this sandwich to these waste products. So there's 4 stages involved in this process. They are called ingestion, digestion, absorption, and elimination. And we're going to look at each one of them and see what they do. The first one is ingestion, and simply means getting the food into your mouth. The second one is called digestion. It basically means making big food particles into smaller ones. For example, we start with a sandwich, then mush it up into your mouths. Eventually they'll end up as big molecules, and at the end we have small molecules that can be absorbed by our blood. That's the next step, absorption. Absorption basically means absorbing all the nutrients into our blood, and it's done in the intestines. And the last one, elimination. It means getting rid of all the waste products that we don't need. So let's look at where all of this happens. We can see that the ingestion happens in our mouth, getting the food into your mouth. There's already some digestion happening in your mouth. It's called mechanical digestion. Mushing it, chewing it, right, with our teeth. Afterwards, it goes into our stomach. That's where most of the digestion happens, and this is called chemical digestion, making the big molecules into smaller ones. After that, in the intestines, right here, we can see that there's also some digestion going on, but also absorption, so the nutrients going into our bloodstream. And finally, everything we don't need is eliminated through our anus. And that was it for today. Thank you for watching.
Alright, up next, let's dive a little deeper into digestion. There are two main types of digestion. Number one being intracellular digestion. Hydrolysis of food inside vacuoles is called intracellular digestion. So as you can see over here, you have food being absorbed by the cell, and that's intracellular digestion. Next, we have extracellular digestion, which is where hydrolysis occurs by the breakdown of food in compartments that are continuous within the outside of the animal's body. So over here, as you can see, we have a hydra. Food will go in and break down in this area. All right, we're going to send it over to one of our field reporters to tell us more about intracellular digestion.
Intracellular digestion occurs within food vacuoles inside cells. These food vacuoles fuse with lysosomes, which contain hydrolytic enzymes. During this fusion, food comes into contact with these enzymes and digestion occurs safely without damaging the rest of the cell. An example of an organism that utilizes intracellular digestion is a sponge.
Thank you for that info. Next, as you're all expecting, extracellular digestion.
On the other hand, most animal species use extracellular digestion. Here, food is broken down into compartments throughout the body, and enzymes are secreted by the cell to break down the food particles into pieces small enough to either be diffused, transported, or swallowed by the cell. This allows these animals to consume much larger food than organisms that only digest intracellularly. Animals with simple body plans may have a gastrovascular cavity, which is a digestive compartment with a single opening. An example of this would be a hydra. Animals with more complex body plans have an alimentary canal, which is a digestive tube with two openings, a mouth and an anus. These animals are able to simultaneously ingest food and digest food.
All right, up next on our list of things to talk about today, we have feedback circuits. So we're going to explore the ways that obtaining and using nutrients are matched to an animal's circumstances and the animal's need for energy. So there are going to be 7 main concepts of feedback circuits. We'll start with the first one, regulation of digestion, which basically means that processing and digestion is activated stepwise, and this allows for us to have long gaps between our meals. We'll send it over to a field reporter to learn more.
Now, since the digestive system is not continuously active, it must be regulated. The food, as it passes through the digestive system, triggers different signals that will secrete different digestive juices throughout the process. The endocrine system plays a key role in this by making sure that each hormone is present during each secretion. Now, we'll send it over to Cassette to talk about energy allocation.
Thank you, Tyler. Now I'll be talking about energy allocation. Food produces chemical energy for metabolism and activity, so the food that you eat is used up in your daily activities. Bioenergetics is the flow and transformation of energy in an animal, and the flow determines nutritional needs of each animal. The energy that you gain from eating is converted to ATP, which allows for cells, organs, and organ systems to basically keep you alive. Energy is used for biosynthesis, energy storage, and reproduction. Well, ATP that is. And heat is released when that ATP is used. The sum of all the energy an animal uses in a given time, or its metabolic rate, determines the necessary intake and energy expended for each animal. Metabolic rate is measured by observing an animal's heat loss, the amount of oxygen it consumes, or the amount of carbon dioxide that it produces.
Next up, minimum metabolic rate. So the very unscientific explanation of this is basically if you have a chill day where you watch Netflix all day long and do absolutely nothing. Your heartbeat still has to happen, your brain still has to function, blood has to flow, all that good stuff. And the calories required during this time are your minimum metabolic rate.
Now remember that all animals, even humans, have a metabolism. But animals must maintain a minimum metabolic rate for basic functions in the body, such as cell maintenance, breathing, and even keeping a steady heartbeat. Now, the minimum metabolic rate of a non-growing endotherm that is at rest, has an empty stomach, and is not experiencing stress is called the basal metabolic rate, or BMR. The metabolic rate of a fasting, non-stressed ectotherm at rest at a particular temperature is called its standard metabolic rate, or SMR. The average BMR for an adult human averages about 1,600 to 1,800 kilocalories for males and 1,300 to 1,500 kilocalories for females. However, the SMR of an American alligator is about 60 kilocalories per day at 68 degrees Fahrenheit, which is less than 1/20th the energy used by a comparably sized human adult.
All right, next up, regulation of energy storage. So when an animal takes in more energy-rich molecules than it needs for metabolism and activity, it stores the excess energy.
Now, we all have on occasion one too many chicken nuggets, but where exactly does that excess energy go? First, it is stored in liver and muscle cells as glycogen. Once those fill up, other excess is stored as fat inside. The liver glycogen is used up when more calories are expended than are being taken in. Then the muscle glycogen and fat. Fats are able to store the most energy, and people can last several weeks without food due to these fat deposits.
Next up, glucose homeostasis. Glucose homeostasis is extremely important in controlling energy storage and also maintaining metabolic balance.
The breakdown and synthesis of glucose is extremely important for homeostasis. Glucose is used up for cell respiration and biosynthesis of many different components of the body. The chemicals insulin and glucagon regulate glucose synthesis and breakdown. Once you eat a meal, your insulin levels increase, and that prompts glycogen production. And the opposite goes for glucagon, prompting glycogen breakdown between meals. The pancreas produces these signal chemicals, and pancreatic alpha cells produce the glucagon, while beta cells produce the insulin. These are all incredibly important for glucose homeostasis.
Moving on, our next thing on the list, diabetes. All right, so this is kind of falls under the category of glucose homeostasis. So diabetes is a disease caused by a deficiency of insulin or a decreased response to insulin in target cells. So this is obviously a big issue in our culture. We'll send it over to a field reporter who'll learn more about it.
A number of disorders that can affect your glucose homeostasis and can lead to potential serious complications such as heart failure, maybe even clotted blood vessels, eyesight, and kidney failure. One of the best known disorders involving glucose homeostasis is known as diabetes. Diabetes is a disease that causes a deficiency of insulin. The blood glucose level rises, but cells are unable to take up enough glucose to meet metabolic rates. There are two main types of diabetes. Type 1 refers to an autoimmune disorder in which the immune system destroys the insulin, producing beta cells of the pancreas. Type 2 refers to failure of target cells to respond normally to the insulin. Type 2 diabetes is the 7th most common cause of death in the United States.
All right, last on our list of feedback circuit concepts is going to be regulation of appetite and consumption. So, as we all probably know, consuming more calories than the body needs for normal metabolism or overnourishment can lead to obesity, the excessive accumulation of fat. So, for this last concept, we'll send it over to a field reporter and learn some more.
Now, regulating appetite and consumption is extremely important for survival. Consuming more calories than the body needs for normal metabolism or overnourishment can lead to obesity. Obesity contributes to a number of health problems, including type 2 diabetes, cancer of colon and breast, and cardiovascular disease that can result in heart attacks and strokes. Obesity is the cause of about 300,000 deaths per year in the United States. However, our body works to counteract obesity. A network of neurons relays information from the digestive system to regulate hormones related to appetite. This controls our appetite in relation to regulating the amount of food that we consume. Now let's go to Riley to conclude our newscast.
All right, ladies and gents, this concludes today's program of HS News. Hope that you've enjoyed your time on the show. Special shout out to our field reporters. You guys did an amazing job. This is all we have for y'all. Here are some citations because that's important. Thanks for watching.